All right, in this example, we're given the graph of a population, and it appears that the population is growing, but it's reaching some limit. It's reaching some limiting population. This is often called the carrying capacity of the environment, right? Where eventually, a population grows, um, but doesn't grow forever because the environment can only handle many so much population before it starts running out of resources. But this graph shows this population reaching a limiting population, and there's an inflection point on the graph, and the inflection point occurs halfway toward the limiting population, all right, L over 2. And so the question is asking, what is the significance of the inflection point to the population? All right. Well, you can see that the population is increasing. It's the first derivative of this population would always be positive, right? Everywhere. Now, let me just mark this reference point. Let's call this t equals a, right? Let's say that that's a. Then we can see that before, let me just write this down, before t equals a, right? So before t equals a, what's happening? The population is increasing, and it appears to be concave up, right? It appears to be concave up, switching to concave down. So what does that mean for the population? If the concavity, if it's concave up, right, then that means that the population is growing faster and faster, right? These slopes are increasing. So you look at a slope down here, versus a slope here, you can see it's steeper. So the slopes are increasing, meaning the population is growing faster as time goes forward. All right, so then after time t equals a, let me write that down. After t equals a, now what's happening? So if I look at the slopes, right, it's a fairly steep slope here, and it's becoming more and more shallow, right? So the growth is slowing down, right? The population is growing slower as time goes forward. Now, we were asked about what's the significance of the inflection point, right? That's the point at t equals a. Right? At t equals a, what's the significance of that inflection point? Now, if you notice, the slope of this of the population is essentially giving you the growth rate, and you can see that the population is growing faster and faster because it's concave up until you get to a, and then the slopes are becoming more shallow, so the slopes are decreasing. So it's growing at slower and slower rates. So the slopes are increasing, and then the slopes are switching to decreasing, and so the population is growing the fastest at t equals a, right? So the population is growing the fastest. Right? So it's essentially the maximum growth rate, right? It's the maximum slope, okay? Because the slopes are increasing until you get to that inflection point, and then the slopes start to decrease. And so the inflection point represents the time when the population is growing the fastest. All right, I'll meet you in the next video for the next example.